Hello grade 8 students, welcome back to our fourth video in our geometry series. I miss all of you and I do hope we'll be back together again before long. In the meantime, here's our next lesson. We're going to be taking a look at the properties of angles that you get with parallel lines and a line that crosses them. Our lesson will look like this. We'll take a look at a relationship called alternate angles, then corresponding angles, then interior angles, and then we'll solve this problem together at the end. So let's move right into that. This is my rather pathetic attempt at drawing sort of like a farmer's gate, if you know what I mean. So you might have a post over here holding the gate up, and then the other one that it latches onto, and the gate would swing in and out. And the reason I've done this is you can see three boards running along this way that are parallel to each other, and then the one that crosses it at an angle like this, which is really what creates the structural integrity for the gate. And this has a special name in geometry. This one that crosses is called a transversal. So if you look here, these two lines indicate that they're parallel using a little single arrowhead on each line. And here's a line that crosses them. Now it doesn't cross them in the same way as this one does. It's at a different angle. But nonetheless, it's still given this special name called transversal. And whenever we have parallel lines and a transversal crossing them, we have a number of relationships that exist there that are worth taking a look at. So let's imagine that we knew or we measured that this angle was 50 degrees. Those of you looking at this diagram right now might be able to look elsewhere and say, hey, I see a few other angles that look like they're exactly the same measure. The one that I want to point right now is this one right here. It has the same measure as the one on this side. You can test it yourself, make parallel lines, cross it at any angle you like, and then measure this angle and the one on the opposite side on the other parallel line, and you should see that they're exactly the same measure. Now, to assist us in finding that when you have a complex system of lines, we look for something called a Z. So this relationship is often called Z pattern, and I'll show you where we get that name from. If you follow my highlighting here, you will likely be able to see, I hope that comes through on camera, that there is a Z formed here. And pardon this language, but the angles we're interested in are the ones that are in the so-called armpits of our Z. So they're on that sort of that inside, the crook of the Z. And what we can say now is that this angle, which would be the one up here, which would be CBF, we can say angle CBF equals 50 degrees. And although it's called a Z pattern, the correct geometric term is that these angles are alternate to each other. So we would just write in here that it's alternate. And again, we're going to use short form so we don't go crazy writing words out over and over. It's alternate to the angle given, which was BFE. So that is your typical Z pattern or alternate angle relationship. Another one we can look at, I'll set it up over here for you. You might notice if I was given this angle over here, and let's say that was 45 degrees, you might notice another one that looks very similar. Of course there are a few, but I'm thinking about this one over here. Very similar to the one we have on this side. Now, this is sometimes called the F pattern, and I'll show you why that is. You need to use your imagination a little bit, but we're going to draw, hopefully, what appears at least a little bit like a capital F that's fallen over. So the F right here, and it's fallen over on its side. And again, we're kind of looking at, forgive the terminology, but the armpits of this F. And if I give just a few letter names here again, so that I can identify a few things. be enough already. I can say that angle DEB is, you guessed it, 45 degrees. Why? Because it is corresponding to this angle, ABC. So when we have the F-type relationship, we say that these angles are corresponding. When we have a Z-type relationship, we say that these angles are alternate. So we can now say that angle DEF is equal to 45 degrees. And that is because it is alternate to angle ABC. Okay. We have one more relationship to look at. On our original list here, we've already checked off Z pattern and F pattern, alternate and corresponding. So that brings us to interior angles, sometimes called the C pattern. And I'll try to point that one out to you right now. Let's, boy, I seem to be using that 45, 50 degree angle quite a bit. Let's say this is 50 degrees. There's another angle in here that isn't 50, but it's related to this angle. The one I'm thinking of is right here. And I'm going to show you why it's sometimes called a C pattern. Hopefully you'll be able to see this, pardon the pun. Kind of a C shape there in our angles, and again we're on the inside of that C, kind of like the armpits of the C. And what we know about these two angles is they are supplementary because of this interior angle. In other words, these two will add up to 180 degrees. There are any number of ways to demonstrate that that is true, but I might leave it to you to explore that if you're curious about it. But since these two have to add to 180, we know that this one must be 130. So I'm just going to add a few letters again. H, I, J, K, L, M. I think that might be enough for now. And let's write down what we can say. So let's imagine that we measured or were given this 50 degree angle. We could then say that angle LIJ, this one here, is equal to 130 degrees because it is interior to angle ILK. And that would be a sufficient way to prove that. Now, they're not always quite as pretty and obvious as some of these have been drawn. So let me give you an example. I might have a parallel lines here and a transversal. But I might be looking at, for instance, this angle. A little bit greater than 90, let's call it 95 degrees. And let's say that I needed to find the value of this angle over here. Well, in this case, it's part of a Z, it's just that the Z looks a little bit stretched out. I'll try to highlight it for you here. So there's the Z, but it doesn't look quite as Z-like anymore. It's as if we pulled it and stretched it in this direction. The armpits are starting to look less like armpits because the angles are opening up, but nonetheless, these two are still related by the Z pattern and are said to be alternate to each other. Okay, carrying on then. We've now taken a look at all of the different relationships that we might need to deal with. And let's solve this problem together. So here we have a system of lines, and these are the angles we've been asked to figure out. And we want to use proper terminology to show our math thinking, of course. First one, angle HBC. So here's HBC. This is the angle that we're interested in finding. At first, it could seem a little bit daunting. Oh, there is one more piece of information that I need to have in here for us to be able to solve it, and that would be that this one is 82 degrees. Some of you might be thinking all of a sudden, oh, that just got a whole lot easier to solve. But let's take a look in case you haven't seen it yet. We have a bit of a Z relationship here. So if I come across here, and then down, and then across again, There's my Z, and these two angles are in the armpits of that Z. So you guessed it, the angle measure is 82 degrees, and it's because it is alternate to angle alternate to angle BCF. Okay, so that's one. Now we're supposed to find angle AFC. AFC. So this angle right down here. Now, if you look carefully, you should see there's one large triangle here. And we know two of the angles in that triangle. You might recall that angles in a triangle add to 180 degrees. So we could add these, subtract them from 180, and that should give us this angle right here. So let's do that. 82 plus 23, that's going to come out to 105 degrees. And when I subtract that from 180, I end up with 75 degrees. And so that is the measure of this angle, 75 degrees. We already know that's 82. So now I can say angle AFC is 75 degrees, and the way we found that was by using angles in a triangle. Good. Next angle we're supposed to find, AGB. AGB. Now for this one I'm going to use a different color marker. It might start to get a little dark on here, but let's see what we can do. So AGB, you're going to really have to use your imagination with me here. See if you can figure out what of our three relationships this one is in. In your mind, you're going to have to turn it completely upside down. You may notice that we have ourselves a capital F, and that relates this one and that one very nicely. They correspond to each other, and so we know that this angle is 75 degrees. So I can now say 75 degrees over here, and the reason, it's corresponding to angle CFG. Okay, good. So in other words, once you've figured out one angle, you may then use that to figure out your other angles. One to go. Angle BGF. BGF. So this one right here. Now, again, this is about filtering out information that you don't need in the picture. If we can get rid of all of this mess, you might be able to see that we just have a straight line here, and then this creating these two angles on either side of a straight line. You might recall we call those angles supplementary. They add up to the straight line, the 180 degrees, and so I can find this one by subtracting this one from 180. And 180 minus 75 is 105. So we know this one's 105 degrees because it's supplementary to angle BGA. And so I can write that in right there. So that's a solution. Now I know for some of us you were able to fast forward through this video. For others it moved a little quickly. Feel free to rewind, look again. Also, I'm going to try to make myself available for answering questions. But in any case, do get on to Classroom today, check for your assignment, be thorough, check your answers, and ask questions if you have them. Hope it goes really well. Bye for now. Can you see? It's just that easy.